this is the last video in this lecture on web service composition. Since service composition is not actually the core content of this class on service development and engineering, we intentionally kept the examples and the explanations simple, just to give you an idea of what web service composition is about. And we stayed at a high level of abstraction. We showed some examples of XML, but we didn't go into real code examples or similar. So you might ask, what next? So what's next in service composition? Actually, there are many things that we could do and that we could have explained more. And one of the key things is just from your side, just try to develop your own composite web services. And in the class, I think you will do this by manually developing some service composition. But then there are, I would say, two key topics that we didn't touch in these videos, and that would deserve some more attention in the future perhaps. One is advanced composition concerns. So I'm thinking about specifically exception handling, so how to deal with exceptions that occur during the runtime of your service composition. So as said, you execute with the orchestration engine, for example, your workflow. What happens if one of the services is suddenly not available, or whether communications are broken at some point? This is called exception handling. Then, somehow similar to exception handling, we have transactions and compensations. What are transactions? Just like in database systems, imagine you have a transaction, or you want to move. Let's go back to the example in the last video. You want to move the 10 million euros from one service to another. Then it's very important that you do all the operations involved in this moving of money in one atomic transaction, it's called, meaning one atomic block. If only one of the actions or of the activities inside this block fails, it is very important to just go back to the state before executing the first activity of this block. And so this is then called compensation. So if you partially already send money from one account to another, you will have to send the money back to the original account and retry to execute the whole transaction. So this is one of the complex and advanced aspects we didn't touch, but that are very important in practical contexts. Then of course, security. Security is always a concern. We kind of hinted at security when we spoke about the middleware services, but then we said we only focus on business service. However, just like transactions, also security is a very important aspect. And security in web service composition means encryption of messages, authentication of users. We may have protocols for non-repudiation of messages and to do reliable messaging and so on. So there are many aspects that we know from generic networking systems that also apply to service composition, and that are very important when you want to do a really mission-critical service composition. And finally, we spoke about contracts in the context of choreographies, where the contracts, they're specifically focused, or let's say only focused on the functional side of the collaboration between the web services. So the functional side is which messages are exchanged between the services. But then there's another kind of contract that rules service consumption in general, and of course that is very important then when consuming multiple services in the composition of multiple services, which is quality of service. So the quality of service is response time, the quality of data exchanged between services, and I don't know, cost and similar. And for this there are contracts which are called service level agreements that one can sign between the service provider and the consumer. And these service level agreements, they need to be monitored at runtime in order to assess whether both parties comply with the service level agreement. This is another advanced aspect that is very important in practical settings, but we didn't touch here in these videos. Then, as I said, there are two key aspects, one where these advanced composition concerns, and then finally there's automation. So the web service context, there's a lot of standardization, there's a lot of uniformation ongoing, and all this helps automating things. We have seen that in the case of Beeple, it's an XML language. There we also have an Eclipse plugin, the Beeple Designer, that provides some kind of graphical UI on top of Beeple. But the abstractions provided by that graphical tool are actually not very sophisticated. They just map the low-level Beeple operations into graphical constructs one-to-one. But there you can imagine higher level modeling tools, higher level model driven development instruments that mask and automate some of the development aspects much better. So instead of going receive, invoke and assign to variables and so on, there could be just one modeling construct already embedding a whole fragment of composition activities. And we can apply model-driven development essentially in two different contexts when we talk about service composition. One is the service composition itself, meaning the modeling of the composition logic, of the integration logic. Another one is model-driven development or model-driven specification of data transformations. So there are lots of research works working on both of these sides. One is the composition and one is data transformation. Instead of writing scripts to transform data formats from one into another, there are instruments that allow you to graphically map attributes from let's say the output message of one service to attributes of the input message of another service, and then to automatically generate the data transformation logic. Then always talking about automation, there are approaches and attempts to completely automatically compose services. So with the model-driven development, we essentially have reuse of code, meaning there are modeling constructs that are just, let's say, placeholders for reusable codes or pieces of code that are then used to execute the composition. But then there are really approaches that try to automatically compose web services. About the automation, there are two essential approaches. One is semantics-based automatic composition, and the other is synthesis. So in the semantics-based composition, the idea is that we take the descriptors, meaning the WSDL files of the web services, and we enrich them with machine-readable descriptions that can be parsed by a machine and that allow the machine to understand whether two WSDL files match. How does it work? Essentially, you can imagine that there is a central ontology. It's like a dictionary or a data model, and you map all the activities and all the data fields in each individual WSDL file of the services to this ontology. The ontology is the lingua franca the machine understands and the machine follows to then match the interfaces of web services. So how does the actual automatic composition work then? If I want to have a specific composite service, I just write my own WSDL file, description file of the ideal web service I would like to have. I hand it over to a so-called planner, and the planner takes all the available WSDL files and tries to understand how to combine these web services in order to obtain an overall interface that is similar to the interface I provided in input. And this is possible thanks to the availability of the semantics that annotates the pure syntax elements in the WSDL files. Then the synthesis is the most complex approach to automatic composition, and this is a really tough also research problem, and there's a lot of work ongoing in academia on this side. So what's the idea behind synthesis? The synthesis goes perhaps one step farther compared to semantics-based approaches, and it tries to derive a composite web service from individual web services by describing both in terms of state transition systems, that is, automatas. So it kind of recognizes that all the web services, they in general are stateful and they in general have a business protocol associated. So it models each service explicitly as a business protocol, as a state machine, let's say, and then the problem of synthesis is, given the state machine of my ideal target service composition, trying to combine the state machines of all the individual web services that are there in a knowledge base and derive a so-called orchestrator that is able to mimic this kind of state machine. So we go from pure description in the semantics-based approaches to state machine representations in the synthesis approaches. And these latter, especially the automation approaches, they are really research concerns, while the advanced composition concerns like exception handling, transactions, and so on, these are common practice, and they need to be mastered already in today's web service compositions. With this summary of these advanced features and of the automation opportunities in service composition, we can now close also this last video in this chain of videos on service composition. I hope you enjoyed these videos. I hope you got interested in the topic, and I hope you are now just eager to develop your own composite web service, either by coding or by using any of the available tools. Thanks for following.